We're still starting to kind of get more into the swing of things here, because this is day 3, and it's called permutations. You might have heard the word before, and it's a way of putting objects in order. So our warm-up for the day is we have 3 people. We have Courtney, Rose, and Hala are running a race, and we're listing the different orders they can finish, first, second, or third. So to do that, we're actually going to list them off. We're going to list them off and then count how many we made. So we have first place, second place, and third place. Okay, so I'm going to do a C for Courtney, R, kind of like how we did for our tree diagram, so you're not rewriting the full word all the time. It's just that first letter helps indicate which person we're talking about. So, for instance, for the first option, I'm going to keep these in the same order that I just wrote them down. So we have Courtney, Rose, and Hala. Courtney could get first, Rose could get second, and Hala could get third, but Courtney could also get first, Hala could get second, and Rose could get third. So now we have our 2 options for when Courtney can get first. Now I'm going to say when Rose can have first place. When Rose gets first place, we can either have Courtney or Hala in second place, but I just put Courtney for this one, and that leaves Hala left. And Rose can get first place again. Now I'll do the vice versa of this one up we just did previously. So Hala could get second, and then Courtney could get third. Now Hala could get first place. So I'm going to put our 2 options down here. We could have Courtney in second, and then Rose in third, or those 2 flipped. So we can have Rose in second and Courtney in third. Now we have all of our different outcomes here. If we add them all up, we have 1, 2, 3, 4, 5, 6 different options. So we have that 3. So in that for first place, let's see, I'll do first, second, and third place. In that first place, and before anyone gets first place, you have 3 different options for people. So let's just say there's 3 people that could get first place. But now for second place, if someone has already gotten first place, there's only 2 people left that could get second place. And last but not least, for third place, if you've already assigned a first and second place, there's only 1 more person left for third place. So then with our counting principle, multiply those across, you get 3 times 2 times 1, 6. So those are matching up. And I'm going to go on to the next slide. I mean, kind of similar, but we'll be doing something a little different. Oh, I think I have, okay, let's switch these 2 slides here. Awesome. Now, how many different ways can 3 people stand in a straight line? I'm going to do something similar. I'm not going to list out our different ways. I'm going to do kind of how we did for that second step in that last problem we just did. So we have our first person in line, second person in line, our third person. I'm going to do 3 different colors for our different options here. So we have a black stick person, we can have a red stick person, we could have a green stick person. Oh, that's supposed to be green. Green. Oh, what happened to our red person? Let's fix them. They deserve a body. There we go. Let's say we have those 3 different colored people, or different people wearing different colored shirts. So we can have 3 people. Let's say we assign the person in the black shirt to get first place. Oh, what in the... Come on, black. There we go. The person wearing a black shirt can get first place, and there's 3 people that potentially could. But the person with the black shirt already got picked, so that leaves the red and the green person left. So there's 2 options, and let's just say we picked the red person to get second place. Let's say the second person's second in line, and that just leaves that green person there to be the third person in line, and there's 1 option. So again, with our counting principle, we have 3 times 2 times 1. If we multiply these straight across, we have 6. And in the next slide, I'm going to tell you what doing this 3 times 2 times 1 stands for. And that is called factorials. You might have heard that before, but a factorial, you know what's a factorial when you see the exclamation mark following the number. And what that exclamation mark means is that you're taking that first number. What if it says 6 factorial? Wow. Oh, talking's hard sometimes. And then we can rewrite that same number here again. And then you're going to multiply it by one number smaller than the most previous one each time until you get to 1. Because if you multiply by 0, it makes that whole thing 0. We don't want that to be 0 because clearly 6 factorial is not 0. So you go down until you reach 1. Let's say it was 5 factorial. It would be 5 because that's the starting number. That's the number that is in front of the factorial. So you have 5 times 4 times 3 because it's getting smaller each time, times 2 times 1. And we stop at 1. So what is 6 factorial? Well, you can either type it in on your calculator, or you could use Desmo. Some calculators do it, not all. Like if you have a basic standard calculator, it probably doesn't have factorial. But if you have like a graphing calculator, I think scientific calculators might have it, depending on your calculator. But Desmos, all you have to do is type in a exclamation mark right next to the number, and it will solve it for you. But essentially, it's saying 6 times 5 times 4 times 3 times 2 times 1. So I'm going to type that in on my calculator really quick. 6. If you're on the TI-84, you hit 6 and you hit the math button. You go all the way over to probability, down to option 4, factorial. 6 factorial is 720. But you can also just type in 6 times 5 times 4 times 3 times 2 times 1 on your calculator, and it will still get you that same answer. It's a little more tedious for numbers that are like 10 factorial, like that. You might want to just do the shortcut and type in 10 factorial or something on Desmos. The same goes for 5 factorial. Gets you to 120. So now we'll move on to the next one. Now we'll get some practice with doing this here. Oh, we just did 5. Wow, okay. Well, I just realized we just did 5 factorial. And what was that again? That was 120. Now here, it looks like it's 4 factorial over, times 1 here, over 3 factorial. But before you go and type all this into your calculator, I'm going to teach you a little shortcut. We know that, remember how you have the same numbers on the top and the bottom of your fraction? Like, for instance, if it's, I'll say 2 over 2, it just simplifies to equal 1, because if you divide anything by itself, it's just 1. So we're going to have that same rule apply here. So the 3's can cancel out because 3 divided by 3 is 1. The 2's could cancel out for the same reason. 2 divided by 2 is 1. And the 1's could cancel out because 1 divided by 1 is 1. And that just leaves you with 4. So we know that 4 factorial over 3 factorial is just 4. Now we're going to apply that same rule here, because we know that this is going to end up being 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. And you could either do the same process we just did up here with canceling out the same numbers, and then it leaves you with 6 times 5, or another shortcut within doing factorials, so like kind of like a shortcut on a shortcut. We know that 6 minus 4 is 2. So you're basically subtracting these numbers here because we know they're going to line up down here. So you're just going to be multiplying those first 2 numbers. So we have 6 times 5 is going to get you to 30. Oh, that's a weird 0. Oh, 6 times 5 equals 30. There we go. That's a better 0. Once again, we knew that all we had to do was take 6 times 5 because we knew that 6 times 5 times, well, that if we had the times 4 times 3 times 2 times 1 in the numerator, and we did 6 factorial, the 4 factorial would cancel out that 4 times 3 times 2 times 1. So we just need to write down those first two numbers. I'm going to do that same rule, but apply it to up here. But I'm not going to write out 1,223 factorial. That's just going to be way too much work. And your calculator, it's way too big of a number for your calculator to even solve. But since we're dividing it by another large factorial, we're going to do that same shortcut we just did up here in number 3 and apply it down here. So we know 1,223 minus 1,220 is 3. So all you have to do is take 1 times. So that means it's just going to leave you with those first 3 numbers you're multiplying in that first step of 1,223 factorial. And I think this is going to be way too big of a number to calculate, but essentially it's getting at you knowing that this is what you're multiplying. It's the same process we just did in number 3, but we're applying it to a larger number. So you can't just type that in on your calculator because that'd be way too big of a number. It's going to give you like 1 point something times e to the whatever power. So anyways, now I'm going to continue on here. And we're going to see how many different ways that Miss Brasso can watch the Harry Potter movies. And there are 8 movies. So we know that there's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So let's say this is the first, second, and then so on. So it goes up to 8. So the ending is the 8th one that I would pick to watch. So that first spot here, we could have, this is going to be relating back to factorials. It could be how many different films can I pick for that to watch first? We haven't picked one yet, so we know there's still 8 options. And then how many different options are left if we already picked one to watch for our second one. So let's say I wanted to go in order here. So let's say I watched the first one. That means there's 7 more left for me to pick from. And then this order is going to continue all the way through. So say for my third option, my third movie the third movie I picked to watch, if we already picked the first and the second one, there's 6 movies left. And this pattern is going to carry all the way through. Remember, see, it kind of looks like it's the same thing as saying 8 factorial. So I'll just continue writing these out. Times 5, times 4, times 3. Because when you get to the last movie, if you've already watched the first 7, there's only 1 more movie left for you to watch. So that's why multiply by 1. And that's where we get our 8 factorial from. And 8 factorial, if you type that in on your calculator or on Desmos, you're going to get 40,320. So that is the same thing. This is a problem where you would do factorial. So again, if you have any questions, feel free to email or just ask away. And then there is a homework quiz on Schoology along with the homework itself. And I hope you guys are all staying safe. Make sure you keep washing your hands, being sanitary, staying in the house, staying safe. Have fun with the homework.